and I'm from deepastronomy.space, and you're watching our weekly get-together with Dr. Bryan Keating, who every week seems to have somebody new and amazing to talk to. And this week, we're going to talk about about an interview that Bryan did with the first author of a paper that you may have heard something about in the news lately about these. There should be 36, I guess, alien civilizations in our galaxy. And so Bryan does what he always does, and he snagged a really good interview, and he's going to be here to talk about it with us. So let me bring him up. Hey, Bryan. How you doing?
Tony.
It's good to see
I'm
you again.
doing great. Yeah. And you put me in outer space where these alien civilizations are looking.
Yeah, that's right. It's apparently there's 36 of them looking at us. So,
that's right.
So what the heck is going on? What is this story about, first of all?
Well, kind of
hold on. We should probably introduce everybody to you.
Yeah,
I'm sorry. We didn't do the right thing. Bryan Keating, he operates his own YouTube channel, and he also has a podcast. The link to the full interview that we're going to be talking about is in my description box of this video. We're also streaming on his YouTube channel, Dr. Bryan Keating. So follow him, subscribe to him, do all the things. And he also has a podcast and all that. So why don't you do just a brief intro in case people are watching that didn't see it last week.
Yeah,
who you are and what you do.
For the 99% of us out there who don't know who I am. I don't know who I am half the time. I'm Bryan Keating. I'm a professor of physics and astronomy at UC San Diego in beautiful Southern California, where we have not seen an astronomical object in months because we are suffering from June gloom. You may be familiar with May gray, but we get June gloom, and it's threatening to go into July. I have not seen a celestial object, even the sun, in weeks. Anyway, so people think of Southern California as a sunny destination. But anyway, when I'm not busy doing cosmology or doing the advising that I do for my students, undergraduates and graduates, I'm running the Arthur C. Clarke Center for Human Imaginations Into the Impossible podcast. And by virtue of my vast, what we used to call Rolodex of friends and colleagues in the field, I've gotten access to some of the greatest minds in astronomy and in and out of astronomy. And I've talked to people in physics as well, ranging from Stephen Wolfram to Eric Weinstein, Sabine Hassenfelder, and many of the greatest minds. And this past week, I contacted an old friend that I knew when he was a graduate student at the University of Wisconsin-Madison, where I spent a couple of years finishing up my PhD. And that was Professor Chris Consolis. And he is a professor at the University of Nottingham in the UK. He's originally an American, but he's been in the UK for decades now. And he is also involved with the editorial board of the Astrophysical Journal. So these are entities that publish the most widely read and important in terms of impact journals in all of astronomy. So he took time out from his normal studies of studying the evolution of galaxies to do kind of an update to the Copernican theory and update it to maybe make predictions as to why we have not heard from aliens. So, we've talked a little bit in the past about the Fermi paradox, which Enrico Fermi basically asked, given the likelihood for life and the abundance of solar systems in the universe, even in the 40s and 50s when he made this paradox up, yet we have no evidence, conclusive or not, that aliens have been here. In fact, we have no evidence. So either way, so the thought was, where are they? That basically summarizes the Fermi paradox. There's basically, we know 100 billion stars in the Milky Way galaxy. If each one of them had 10 planets around them, or more planetoids, moons of other planets, then you would expect there to be 1 trillion possible worlds where life could theoretically emerge. So where are they? How come they're not here? And I think Chris's explanation generated a lot of attention because of its specificity. He basically said, the headlines were, first of all, the headlines in the UK are really funny, Tony. You ever notice them? They're like, space boffins. Yeah. Space boffins say there are 36 civilizations. And you're like, space boffins? What the heck is a boffin? But I guess it's their way of saying nerds.
Yeah, I'm reading a William Gibson book right now about the main characters in the UK right now, and he calls it Mirror World, from the United States. It's like Mirror World phone. It rings just a little bit different, and the food's always a little bit he calls it Mirror
Yeah.
World. So
Yeah,
yeah.
they say America and the UK are divided by a common language.
Yeah, we really are,
That's
and the cultures couldn't be further apart. I married someone from the UK. I married she's a
oh,
Geordie, and
oh wow.
you'd think we'd have a lot more in common than we do, but it was, culturally, but it was so different. I lived in the UK for over a year, and it was a real eye-opening experience. And of course, she's really adjusting to being here in America. So
Sure, yeah.
yeah.
So
Okay, so you talk to this guy who's a friend of yours, and this is coming on and as you mentioned, this was paper published in AppJ. This is not just any old journal we're talking about here. This is one of the premier ones in the United States, put up by the American Astronomical Society, and so this is coming on the heels of another paper that preceded it, that also used a similar statistical analysis that said that basically tried to distinguish whether life was common or rare and whether intelligence was common or rare. And we'll talk about that a little bit more if we have time. But this paper seemed to raise a lot more eyebrows. It certainly did with me. So why don't you tell us a little bit about the research and what these guys' methodologies were and what you thought of it?
So as I said, Chris is he's an honest-to-goodness astronomer looking through telescopes, not through telescopes, but using big, powerful telescopes.
Honest to goodness, that sounds like an interesting qualifier.
He's a card-carrying member of a union called the International Astronomical Union. He's an optical astronomer, and most of what he does is study the properties of galaxies. And I think in so doing, he decided on a criterion within the Drake equation. So let's take a step back. The Drake equation is this governing equation that was proposed by Frank Drake in 1961 that had about 7 or 8 factors that went into calculation that would yield a probability and eventually a number of intelligent alien civilizations currently existing in the Milky Way galaxy. So I point out that's almost 60 years ago. Right? So we've had almost 60 years of the Drake equation. And even before that, people were thinking about SETI. And, we did an interview with Paul Davies about his book, The Eerie Silence, which was written a decade ago and is still pretty eerie. We haven't heard anything. I talked to Ann Drury, Carl Sagan's widow, and that episode will be coming out soon on the Into the Impossible podcast. But she basically feels like it's a matter of time, and we've only searched a fraction of a drop in the ocean equivalent, but essentially they are very sanguine about this phenomena that you could in fact make a calculation which would indicate with some degree of accuracy what the number of expected civilizations would be in the Milky Way galaxy. So his twist on it, his improvement, if you will, was, I always say this, and I gave a talk at the SETI Institute, so I was on enemy territory because I was talking about why the Fermi paradox, why the Drake equation is really kind of a poor representation of what we astronomers and physicists do. The first thing, you remember this, Tony, from your undergraduate days, if you handed in an equation and it just had an answer, it's a lab result or something, and it had no error bar, no uncertainty on it, you probably would get pretty poor marks, as they say in the UK, right? Mm-hmm. You wouldn't be first class. And I always, if you give a result in science and has no uncertainty, it has no meaning. Even if I say, Tony's IQ is 200, and I don't put any error bar on it. You may agree with that, Tony, by the way. But if I don't say with an uncertainty of plus or minus 200, it changes very radically, and it should change the way that you approach the central value of that number. So the main headline was 36 civilizations in our galaxy. In The Guardian, Space Boffins, the equivalent of the New York Post or whatever in London. And it was good fun, but they never mentioned there were very large error bars that surrounded it. And that's what I wanted to get into with Chris. So I went in deep in a discussion with him, and I asked him, first of all, and I'm glad I did, because oftentimes, he's the professor, he's a big shot, he's super well respected in our field, like any editor of a major journal is. incredibly accomplished. So I asked him, well, who's his co-author? Tom, who's the first author on the paper. And he said, oh, I'm so glad you answered that. You asked that question because, I want to give a shout out to Tom, not only because, he's the first author and he was working with me, but also because the analysis that was done is mainly a likelihood or probabilistic analysis, not an astronomical analysis. There's one little twist that Chris added that makes it a more astronomical than usual, and that has to do with the formation rate of stars in the galaxy. We can talk about that. But most of the heavy lifting in this paper was done by his co-author Tom, and Tom's contribution was really deep in probabilistic. Tom Westby, his probabilistic analyses, according to Chris, made the paper's results possible. And so I'll just tell you, the headline should read, there should be at least 36 plus 175 minus 32 civilizations within our galaxy. And this is called, he considers this a lower limit. I really want to talk to you, Tony, someday. What does it mean to have a lower limit? What does this actually mean? And so how this paper was done was thorough. It was methodical, but the headline that's being taken away is not representative, really, of their main conclusion, which is in the error bars. That's the thing that most non-scientists don't realize. It's really in the error bars.
Yeah, and I thought that the error bars were large enough such that 0 was actually a possibility. Ethan Siegel did a paper or did an article on this paper, and he mentioned that where the error bar, I couldn't get to the paper because it's behind a paywall. So I couldn't read the paper itself, but based on his analysis, he was saying that whenever you have error bars that include 0, where it's possible you have none, that kind of makes this whole thing.
That's right. That's right.
So
I want to show you. I'll see if this works. This is live streaming, so this is kind of crazy. I'm using one of these LCD boards. I don't know if you can see it, and then I'm using an Apple Pencil that's broken. So it doesn't work.
Hey, only the best here, folks. We bring
exactly.
The best
it's high tech.
That's
send in those Patreon dollars to Tony. No, he doesn't. So the way that this should look, you talk about distribution. So you're familiar with like a normal bell curve. It goes like this. It has some maximum value. Let's say this is height, and this peaks at 5'9", 5'10" in the U.S. for males. Can you see this, Tony? By the way,
we can see it. Just hold it slow. Don't move it around.
There's a bell curve. I'll try to get the glare off it.
That's it. Just worry about the glare. That's perfect.
So the central value is the mean value. That's the most likely value that you could predict. But this is not the only type of distribution. This is called a Gaussian distribution, and my artistic skills are horrible, but it should look like a bell. That's the famous bell curve. So there's some probability that you could find somebody who's like 90 feet tall, like way, way off, but the probability of that is incredibly, infinitesimally, exponentially small. On the other hand, there's no one that could be less than 0, so it does have a hard cutoff at 0 feet tall. Now, in the case of what Chris and his colleagues are showing, the curve, instead of looking like a perfectly symmetric Liberty Bell kind of shape, would look like this. Draw the axes, and I'll draw over here at 0, and it would look more like this, where you have a peak, roughly, kind of bell-shaped at the very top. This is very large numbers, so this would be over 200 civilizations over here, and this is 0 civilizations over here. And what they're showing is the most likely 1 sigma confidence bound encompasses 68% of the area of this curve.
Lift it up.
Is underneath in the. You see that?
Yeah, lift it up. There you go.
Yeah, there we go. So there's 68% is between 200 and 4. That's 36 minus 32. So there's some non-vanishing probability that there are 0. In fact, it's quite large. Actually, the probability that there's 0 is probably tens of percent or more, and that's with all of the optimistic or realistic conditions that they put into the Drake equations. Single term, really, that revolves around the probability for stars to form with a proper property that's called metallicity. Now, you already thought we're strange out there, astronomers, because we consider anything that's heavier than helium on the periodic table of the elements, we call that a metal.
Yeah.
Right, Tony?
That's right. Yeah.
And so,
Why not?
but now what he's saying is that you can't have a civilization that doesn't have metal, within it, that doesn't have a star, a host star, and its stellar neighborhood in the Milky Way galaxy that has a large amount of available metals. And those metals would be then used to make devices that could then communicate with the Earth. So he focused on his specialty, which involves around what we know about the metallicity and how that traces to stars that form. And he also does an analysis that not every star is equal. As George Orwell said, everybody's equal, but some are more equal than others. The most common type of star in the galaxy are these called M dwarfs. And we thought that, according to him, that even though there's many, many more M dwarfs, which are colder than the sun, smaller than the sun, they didn't think that those would be very likely as hosts for planets that could then maintain life, and then that life could become intelligent, and then that life could communicate. That's the C. So he doesn't talk about SETI, searching for extraterrestrial. He talks about communicating extraterrestrial intelligent civilizations, TEDI. So I know I've been talking for a while. Do you have any questions for me, Tony, right now?
I'm with you. I just want to clarify some of the assumptions that you say have gone into this. One of them was, as I understand it, you've talked about the distribution of what they found and what it looked like, but some of the assumptions were very weird. One of them being, and correct me if I'm wrong, there was a weak case and a strong case, and the weak case was that after 5 billion years of time elapsing, a civilization, it assumed, around sun-like stars with a planet like the Earth in orbit around it, in 1 year, roughly Earth-like, then a civilization must form. That was the assumption, one of the assumptions. And the other one was that it would also be, once it formed, it would have a communicable lifespan of at least 100 years, which is what we've been doing roughly.
Yeah.
Those assumptions seem problematic to me. First of all, going back to that other paper I was telling you about that tried to estimate the rarity or the commonality of not just life, but intelligent life, the conclusion of that paper was that intelligence is probably rare. The jury was out on his analysis, but it was slightly less on the side of being rare than being common. And so here we have two papers using roughly the same kind of math, coming up with conclusions in a different way. One of them says intelligence is probably rare. The other one says we have 36 civilizations in the galaxy, and civilizations must form after 5 billion years for that to work. To me, that seems like a problem. Do you agree with that? Or
yeah, so that relates to what we call priors. So there's a general class of how do you calculate the likelihood that a hypothesis or theory of nature is correct based on a certain amount of evidence. And that evidence can range from, in this case, it's going to be astronomical data. It's going to rest on certain types of errors that you might make. And it may rest on prior information that you've already gathered. So I showed this example before, when I was talking about height or weight or whatever, we don't believe that you can have less than 0 height. That is a prior, right? I don't know if you could really physically contemplate someone who's less than 0 feet tall. But imagine if you applied that same prior to energy, or to as we think about it in terms of charge. You said all charges are positive, or something. You're imposing a prior on top of your argument. So therefore, it multiplies this distribution. It truncates it at a certain value. On
the low end.
Yes.
Okay.
So on the low end. Now, what he's doing there is two things, and the assignment that you said, he's putting on a couple of priors onto this thing. He's saying that life has to last for at least 100 years. I mean, it could be that there's
communicate for 100 years. It had to be actively communicating.
And so a lot of times you get your priors, if you only have one example, the famous black swan, Nicholas Nassim Taleb, if you only have examples of white swans, or in your daily experience, you might say that all swans are white until you have evidence otherwise. And so it's actually a good approximation to do that, but it's susceptible to this confirmation bias that you're going to plug in things that are familiar from your own experience or your locality. So for this, he's claiming 100 years is sort of a typical lower limit. And actually, he's saying if it actually would have been more civilizations if he said that stars that are only 1 billion years old could form stars. So it's actually making it more restrictive and smaller by imposing a prior of about the age of the sun. Now, I pointed out the sun is about that age. And again, he's applying these two priors, and that's the so-called strong case. I think if you loosen it, then it relaxes and you get even more civilization.
That's right. Yeah, that's right.
But you know what's so interesting to me? There's a colleague at the University of Rochester named Adam Frank, who's an author.
Oh, yeah, I've had a hangout with him once. Yeah.
Oh, cool.
Yeah.
He wrote a book called Light of the Stars, and he goes through a similar kind of cosmic Drake equation, but he applies it to the whole universe, and he applies it over the history of the universe. And in the whole history of the universe, he claims there could have been something like a lower limit or even maybe the most probable value of about 20 civilizations. So that sounds pretty close to 36, except that there's 100 billion galaxies in the observable universe. So
right, and he's talking about one in this paper. Right.
Exactly. So I think it's they're wildly in violent disagreement with one another in that sense. So I didn't get a chance to kind of actually I did ask him, but I don't think he read that book, so I didn't think it was fair to question him on somebody else's book. But the reason I think this paper got so much attention was because of the implications. What would it mean if we did say that there was another civilization, and in fact, if one were close by? So how do we know that they're not close by? What Chris and his colleague Tom did is go through and calculate the expected distance between these civilizations, along with some other more astronomical assumptions. So that these planets would have to be in the habitable zone, that they might not be surviving so readily. Most of the stars in our galaxy are near the galactic center, as you know, but that's not as hospitable as being out in the spiral arms. And so there's some contention that they argue for what would be the mean separation in terms of light years. And it turns out we'd have to wait a pretty long time to get those three dots that you see when you're texting your wife and she's typing, like it would take 17,000 years to go from here to the next civilization, according to them. Again, what's the first thing you should ask me? I just told you the nearest SETI civilization is at most 17,000 light years away.
I thought that was at least. I thought that was at least. It was the closest.
It says at most. It's at most. So it's closer than. So that's an upper limit to how far away.
Oh. And what's your question? What's that mean?
What should you ask me? I just gave you a number. 17,000 light years. What's the next question you should ask me?
Oh God, I feel like I'm being tested.
You are.
The next question I should ask you is, what I don't know what kind of star it was.
No, I really do talk about that. What did I say was the problem with the 36 number that we keep hearing about? What's the main part? Like the Guardian and all these magazines put out, they just said 36. They didn't say what.
The error bars. They didn't say what the error bars were.
Exactly.
Oh, okay. Right.
So you should ask me what's the error bar on that number?
Oh, on the 17,000 number. Yes.
Yes.
Hey, Brian, what's the error bar?
Good question.
On that number. Good
Let's
question,
answer
Tony.
that now.
I can be taught.
It's plus 30,000 or so light years, 33,600 light years. And then it's minus, so it could be 10,000 light years closer. So it could be at 7,000 light years all the way up to 50,000 light years, which is half the diameter of the Milky Way, roughly. So if you do think about it in those terms, in terms of communication, which they don't really get into, they're not saying like how would you communicate, what would you transmit to them, but they're really taking like a star formation, a galactic astronomer's approach, using our best knowledge about the state of galactic formation, the stars within a galaxy, the lifetime of stars, how long do stars live for, and what kinds of conditions, namely metallicity, the fraction of materials that are suitable, that aren't in pure gaseous hydrogen and helium form, taking those and applying several different criteria cuts to it to come up with this number, which again has this very, very large uncertainty to it. Again, with certain priors. The priors are what they assumed about the age of the stars having to be above the age of the sun, roughly, or approximately the age of the sun. And there's an error bar on that, too. It's not exactly 5 billion years, or you can't have a baby civilization. So there's some error bars there. And then you go through and you churn a crank. You do, what's called Monte Carlo Markov chain.
Oh, I thought it was Bayesian. It was Monte Carlo?
Well, that's one way to do it. They can do a Bayesian if it's analytic, and they can actually calculate do the integrals. A lot of times, it's even if you believe in the Bayesian kind of hypothesis of evidence given data and priors,
Right.
You still will use a tool like a Monte Carlo Markov chain.
Oh, okay. Okay.
To analyze it, because there's just so many of them out there, and it's not like they're testing the fundamentals of probability. And then the rest of the paper is cute. It's it doesn't require advanced quantum mechanics to understand it. And that I found it very readable, very enjoyable. And the conversation that I had Chris go through a PowerPoint presentation of the kind of the highlights of the talk, and it was really enjoyable. So that's on my podcast. I think it's linked on show notes in my channel, Dr.
Yeah, and I put the link to the full interview in the description, so you guys need to go watch it and learn more about this. Since I only have a limited time with Bryan, I want to get a couple questions out. My first question to you, and then I'm going to read some from the chat, is what did you think of all this? What's your opinion of the results and this whole brouhaha?
I felt for him, because I don't think First of all, the paper came out months ago. I think it came out in April. I remember seeing it earlier this year. And
in
thinking,
AppJ?
And no, on the archive.
Yeah.
So when we have it's called the preprint server, and you can find it there.
Oh, I didn't.
It was submitted in April. Yeah, and I remember breezing through it and really reading it and feeling like, oh, that's kind of interesting, and it's a cute analysis that comes up with some. Yeah, I mean,
cute science.
Yeah, that's it means fun, That doesn't mean
I know. You're cute. You used to describe as an adjective. What science is all?
Cute extraterrestrials.
Science is so cute. It's so cute.
So I really enjoyed reading it, and I didn't make much of it until they came out with this Guardian, and I showed this picture of him in this Turkish newspaper, and then the Sun, the Daily Sun newspaper with the space boffins, and then I felt pretty bad for him, because it's like George Orwell said, and again another George Orwell quote, but he said, a donkey has a magnificent tail, but it's to keep away the flies. So you'd rather not have the flies and not need the tail.
Yeah.
So I felt kind of bad for. I don't know. He might be listening. I tweeted out to him.
Good. Well, good.
So
no,
we'll see. I don't know.
I don't know what I think. I haven't read the paper, unfortunately, so I can't really comment on it about the analysis and the way it was done. But you bring up good points about the error bars. It sounds like it was more rigorous than I was led to believe by some of the things that I had read about it. So that's good. I just wish, and the reason I suspect all of this is that the number didn't turn out to be 42. And I think anybody who knows anything knows that that's what it should have been. So, I mean, that's my only thing. Makes me kind of go, I'm not so sure about this. It's not 42, really?
You know why 42, by the way? Not just the Hitchhiker's Guide. You know what's special about 42, Tony?
No, to me it's always been Douglas Adams, but you tell me.
Yeah, but no. It's the most fortuitous number.
Oh, God.
Come on, people.
Come on.
What do you expect?
He's here all week, folks.
I'm here once a week. And not next week.
All right, I want to respond to Laporta D's comment. Over 4,000 Earth-like planets and only 36. Shouldn't that at least have a 0 on the end and maybe 360? Most of the planets are probably older than humanity and have had much more time to evolve. I just want to point out something. The Kepler Space Telescope, based on analysis from what they've done, the estimates are that some percentage, a small percentage, like 10% or maybe less of sun-like stars have an Earth-like planet around it, depending on how you do Earth-like planet. But of all the planets Kepler found, it only found one that was like the Earth in terms of the star, orbital distance, and things like that. So out of all the stars that Kepler saw and all the planets Kepler found, one was what it came out. So this isn't so low. And I think you might expect several billion Earth-like planets in the Milky Way based on that research, but it doesn't. I don't know. I mean, I tend to believe the lower numbers as far as these planets go. What do you think?
Yeah, well, don't forget the Kepler number is using a very special technique, of occultation.
A subset. That's right.
Transits, and those can only be seen, because Kepler lasted for a few years, and to accumulate enough statistics, you'd like to have multiple orbits of the planet. And even though the planet, so you ever watch Star Wars, Tony?
No, I've never seen it.
You
What
never
is
saw
the
Star Wars?
Wars of which you speak?
Okay,
Of course
so
I see
Star Wars.
Wars.
So remember, how much older than Luke is Yoda?
How much older than Luke is who?
Is Yoda? Remember
Oh,
Yoda?
who knows? Yoda's like
No, he
infinite.
says
Oh,
in the
does he?
chat. How old is Yoda?
Oh,
Let's
I
look
don't.
in Tony's chat or my chat.
Okay.
Come on, Peter. Come on, Raj. I know you can answer it. How old is Yoda? I got Raj. I got Peter. I got Brian. Kuma. How old is Yoda? Come on. you
How
guys
old
can
is
do it.
Yoda? Yeah, it does not say. When does he say that? In Empire?
Anyway, he says he's 9. He goes,
Oh, he's 900.
you 100 years old you are. So he's 900. But what is that? Why? Remember, where is
900
this
what
taking
years?
place? This
Yeah,
takes
right,
place in a
exactly.
galaxy far, far away. Why do they know about Earth? You know, how do they know what the future orbital
Oh, you're
period
right.
of the
My
Earth
own
is?
counsel
Anyway,
will I keep. Yes, I remember the line now. Okay.
Princess got it. Yeah, Princess got it. John is off by Neil got it. Yeah, all these guys got it. 900 years.
All right.
So why is Kepler biased? Why is Kepler the satellite biased? Because it's looking for things that are on an Earth-like timescale. Because the satellite only lasted for what 5, 6, 7 years.
It did its mission for 4,
build up enough
and then it had to. It became K2.
Well, that's right. Yeah. So for 4 years, it could count at most 4 Earth-like years. But what if there was only, the planets that I was seeing had a 10-year-long period or an 8-year-long, it wouldn't detect them. So, because they wouldn't transit. And so,
ideally they said they
Kepler
wanted 7 years
of data. Yeah. So that Kepler number, should be evaluated as something like, again, another lower limit. So what is a lower limit? Again, in the height example, it can't be lower than 0. So that's an upper limit. That's a lower limit. You'd like to have lower limits as an experimentalist. Normally you have upper limits, right? What's the upper limit on the number of civilizations in our galaxy? Well, there's probably not like billions per star. So, even if there were, you could say it's 1 billion times 100 billion. So it would give you a number. It would be a huge number. That would be an upper limit. That's like saying, my height is under 1,000 miles, tall. So it's not very useful. But when you apply a prior, and you have a lower limit and an upper limit, that means that there's an answer somewhere. You may not be able to detect it with present-day instrumentation. For example, we know, you've heard of neutrinos. I'm sure all you guys have heard of neutrinos. We know neutrinos have mass. We know their mass can't be bigger than a certain value, but it also can't be smaller than a certain value. And maybe we should talk about that someday. Neutrino oscillations, neutrino mass experiments, and how we go about getting those. But that tells me, as a cosmologist, I just have to build a sensitive experiment to bring the lower limit up and the upper limit down. Eventually, I'll get bingo, Pater, the neutrino mass. So we like to have lower limits, and that's what Chris's paper provides, at least in the assuming these assumptions are correct.
Right, and that's an important qualifier. Neil Yu wants to know, Brian, what would your final number be after refinements?
So I think that there's none. I just look at the problem. Like, this is going to sound stupid, and again, this is not my field. I am so far out of my lane, Tony. It's not even funny. But I like to
I'd
think
never
about
let
it.
that stop me. I drive an airplane.
I know. And I'll put a link in the chat to my SETI talk where I go through this analysis. I basically say the universe is a certain age, and there's a certain number of civilizations in the galaxy. But instead of trying to estimate the number of civilizations or the the lack of them in the observable universe, or why they haven't come to us, the Fermi paradox, let's do something simple. The Drake equation applied to the San Diego Zoo. So how many people, this is 4 years ago when the zoo was open, okay? How many people are in the zoo right now? And in this talk at the SETI Institute, I go through a calculation, and it comes up with like 10,000. But again, what's the first question you ask, Tony?
Error bars.
Error bars. The error bar is 11,000. So it could be 0 or less than 0, and it could be 20,000. So it's not very interesting. On the other hand, I think about, like, what is the probability that you can communicate? And no one's ever done this as far as I know. How do you actually compute the probability, not of the existence of planets with stars? I believe Chris can do that better than me, probably. But look at all the steps in the chain that lead to just transportation, just telecommunication, just the ability to transmit globally into the universe. And I also made that point to Chris. I said, look, for the first 50 years, all of our signals were scattered throughout the universe. But now we beam them, we put them in fiber optics, we put them in laser pulses. We don't waste energy by broadcasting as a monopole or radiator. or dipole radiator, we beam form Gaussian beams to transmit exactly to Tony and nobody else, because we don't want to waste energy and waste money broadcasting scattershot. So I'd love to see an analysis. This is a thesis project for anybody out there who's intrepid. Look at the probability to form the technology that we would need. Look at all the steps that led up to technology, Maxwell's equations, Hertz, dipoles, just for radio waves. And then what happened before that? Do you think that Hertz was writing by, I mean, he wasn't writing by incandescent light bulb, right? I mean, Thomas Edison discovered the light bulb without a light bulb. You ever think about that?
Mm-hmm. Yeah.
So, and then what was he using? He was using a candle, or he was working at night. Before that, they used whale blubber, you know. And so, what are all the steps that kind of come just for the Earth? Like, we needed petroleum to make oil, to make the factories that then built the radio transmitters and the internet, right? That petroleum comes from microorganisms that lived billions of years ago. What's the probability that there's some energy source? I would say you can't build a solar panel. The first solar panel wasn't built using solar electricity. So how do you make this technology if it's ubiquitous? What's the Drake equation applied purely to technology? That's my homework assignment for next week.
Yeah, and to make it even more interesting, what if is this the only way it could have developed? You have to assume that this was the way, well, it certainly was the way we did it, but is this the only way to do it? Right. And then that opens up a whole different can of worms with your assumptions. So we needed fossil fuels, which needed all this organic decay to happen first. So you look for planets that have a lot of that in it so that they can develop petroleum. But what if there's another way to get the energy out in a different order? So
yeah, I said this to Freeman Dyson. I said, you know what, like, we use whale oil. So what's the probability there are whales on, you know, a planet in the constellation Andromeda? And he like smacked me across the face. But if anybody's interested, I'm serious. If anybody is interested in like doing a project together with me, I'd love to do like a technology-based a Drake equation. Just for that, what did it take to get humanity into a point where we were a KEDI, as Chris and his colleague calls it?
Okay. Raj Luthra wants to know, can current and future telescopes confirm the number of civilizations? Can we ever see these with current or even future telescopes?
Well, I have a colleague here, Shelley Wright, who's building technology not to listen for radio waves, but to look for laser pulses. And, you know, again, nobody knows what the underlying prior is for how many civilizations might exist. It's almost, you know, it's a little bit above what are called, also attributed to Enrico Fermi, these Fermi problems, where he used to ask his class of physics students, how many piano tuners are there in the city of Chicago right now? And they would have to like do these estimation problems, these guesstimation problems. So a lot of the Drake equations kind of predicated on such analyses. So technology could hear it if we knew where it was looking. We have very sensitive receivers, radio receivers, light detectors that can see single photon pulses, that can amplify incredibly low signals. But how do we know what frequency they'll be tuned in at? You know, what if I had to guess the stream key for today, and I guessed, you know, 1,000 combinations a second, we wouldn't talk for a week, right? I mean, and that's just like a 26-digit, you know, combination.
I know. It's like a credit card number. It's like
so.
Huge,
imagine
right?
we had to guess what we were going to use each week instead of relying on this lovely Streamcast technology that you've perfected.
Okay, well, John Suffel is asking, what is that pad Brian was using? By the way, love the book on the Apollo moon landing.
Oh, cool. This is called a boogie board, not to be confused with the surfboards we use here. Well, about $10 or $11 on Amazon. What's cool is you can press on the erase button. So I'll put, you know, my favorite name here.
I think Neil called it an Etch-a-Sketch. Yeah.
It's not an Etch-a-Sketch because you can erase it. It's an LCD tablet. It's about $10 or $12. It uses a battery and it lasts forever.
It's the consummate educating tool. That's what it is. Coffeefish is asking, if dolphins were equipped with arms and hands, would they be able to use fire as a tool? Just wondering if they are intelligent enough.
That's a question for marine biologists, but I would say they do seem to use language. They certainly communicate with one another, hunting, wise, which is their number one, kind of technology. But it's really using echolocation and so forth. It's unclear. There are examples, Jane Goodall and others documented chimpanzees, which are the closest primates to us that have opposable thumbs, They weren't making fire, but they were using sticks to get at termites inside of a mound and using tools. And that requires very complicated 3D modeling and spatial relationships. So that was very complex. And actually to build the first tools, like think about what went into building a flint, like a chopping tool, like an axe head. It's a lot. You see this stone, and then this hominid had to think about, well, in the future, if I expend a lot of calories, which will expose me to being killed by a saber-toothed tiger, whatever, I can chip away and make an edge using another thing, blah, blah, blah. And then I can use that instead of using my teeth to chop through bones and get the marrow inside the bone. It's a very complicated process. So I don't think it's possible with dolphins. But again, that's a good point that he's making, that there could be teeming with life in the universe, but not able to communicate with us because they're not technological.
Yeah. Neil Yu wants to offer I don't know about this, man. We could shoot the sun with pulses of laser light and the aliens will see that. No, that doesn't sound like a healthy thing to be doing. But
I want to keep the sun,
Yeah, but
as long as possible.
Yeah. And then he's commenting about exomoons and things like that. So, yeah, I
did ask him about that. I asked Chris about exomoons because, we don't think that life can exist on Saturn, but Saturn has a moon called Enceladus, and people have thought about might have the properties for. Now that's more like the Earth, right? It's a rocky planet with planetoid. It's bigger than the moon of the Earth by far. It's comparable to Mercury, and it has an atmosphere. So, theoretically, these exomoons could be bases for life to emerge, not necessarily the planets themselves that Kepler can see.
Yeah, they could be sheltering. Life from like M-class dwarfs, for example, which are very flary, and so you can maybe nestle in one of those. So yeah, it's certainly a good place to look. Better and Better is commenting, I would think that any hunting species would be able to develop the intelligence, and that it is only the lack of manipulative skills or their environment that holds them back from further advancement.
Yeah, I mean, there's a complex competition between the needs of the individual, the needs of the civilization. Kuma-san is asking on my chat page, are we not anthropomorphizing and really assigning, and what's another word for that, Tony? Error bar. No. But another word for that is like bias and
right.
priors. When you put a prior on something, you're reflecting a predisposition, which is okay to do scientifically. Of course, not in the real world with people and so forth. But looking at a bias, usually, as I often say, to get rid of a bias, like your thumb is on the scale as you weigh out how much coffee you're going to get. You're going to get less coffee, but you have to do another experiment to get rid of the systematic error bias. The other experiment is the observation that your thumb is pressing down on the scale. Then you remove it. You see you get zero when you zero coffee beans on the scale. For example, during this cosmic coffee.
Yeah. But you know what I think about? I think biases are important to remove, definitely. But when you're talking about the numbers that we're talking about here, with the numbers of stars, numbers of galaxies, numbers of planets in the universe and possibilities, I think even with some pretty significant biases, like anthropomorphizing life in the universe, we're still going to find it. Even with our biases, sure, we can't believe that's the only way, that the only kind of life that's out there. We should remove the bias and then start looking for others. But I think the biases don't get in the way here, at least when you're trying to find some non-null answer, right? So whether it's biased or not, I think doesn't matter.
Right. Yeah, where it does come up is in the context of communication. So there were some people that said you should look for signals, what's called the water hole, which is kind of a play on words because a lot of animals and hominids, congregate in Africa in the savannah, near these watering holes. But in the context of astronomy, it means the 1.4 gigahertz line of the hydrogen. Hydrogen makes a transition between two of its different quantum states. And hydrogen is the most abundant element in the universe, and it makes up water, which is also extremely abundant as a molecule. And there's also water lines, and so that would be ubiquitous. So you would look for a signal, because the aliens would say every astronomer is going to be looking, and another civilization is going to be looking at the 1.4 gigahertz, 21 centimeter line. So we're going to put we are here on that frequency so that we don't get missed. That's a huge bias, right?
It's an anthropomorphic bias, yes.
Exactly.
But it's much better, and you get a much bigger net with that than you do by only looking for, say, episodes of the Jackie Gleason show, right? I mean, you really are, that's really being biased. But by saying that you're looking at this entire frequency or spectrum, I think you're still including quite a bit of possibility there. So my point is that the biases don't necessarily hurt us so much here when you get anthropomorphic about our search.
You have to start somewhere, right?
You're right. That's right. And you're going to find something if it's there, right? And that's a good assumption to make, Yeah. So, okay. Well, do you have to go or do you have time for more?
I got a couple minutes. I got a couple questions on my stream.
Okay, go for it, man.
Let me see what they're asking over here. We answered one from Kuma-san. Let's see over on live stream over here. I think Brian had a question. Is Sol, S-O-L, male or female? Just thinking about Terra and Luna. I think, Luna's a god. I don't know if Sol, S-O-L, has a gender. Let's see. He also says, dad jokes are an art. Thank you very much. I major in the arts and sciences. Brian asks, could a super Earth exist, or Kuma-san asks, could a super Earth exist revolving around a stable red dwarf star? Yeah, if you remember, there were the star system called TRAPPIST, the TRAPPIST system, about 5 or 6 years ago. Actually, one of my colleagues here at UC San Diego, Adam Bergasser, was part of the discovery of that system. I think one of those stars was a red dwarf, which, by the way, I believe it was Jill Tarter, who's a friend of ours, who coined the term red dwarf, and as part of her PhD thesis at Berkeley, or maybe afterwards. So yes, they do believe it. It has certain properties that make it attractive, other properties that make it less so. Some of these things could be so cool that the star would not provide enough solar energy to do photosynthesis, which we might think of as a prerequisite for life to emerge, a complex million scale life. Some stars are fake, Brian says, because they could be Dyson spheres. That's true. So you can't rule that out. And then let's see, life could evolve for a long time. Yep, that's Kuma-san. Do all civilizations? Yeah, we heard that one. Yeah, so those are my questions. Are there any more in your channel? I have 5 more minutes.
Okay, just some comments here.
Yeah.
Unsi Narayan it says, commenting that you're making a lot of assumptions. It's assuming the aliens think like our astronomy professors. Yeah, but my point is it doesn't matter, right? You're still going to find something if the numbers truly are the thing that we need to worry about, the sheer numbers. Oh, surely there's something. Then when you're talking about that big a net, then whatever assumptions you bring in that net is still going to give you something back. It won't be accurate representation because of the assumptions you've made.
That's right.
Much like this paper,
yeah,
and the error bars with which you have. But you should find something. I'm saying the biases won't get in the way. Is what I'm trying. It's the point I'm trying to make. Let's see. Anthropomorphize. That's what Andrew Planet was looking for when he was looking for stuff about Yoda. Oh, okay.
Baby Yoda. Don't forget about baby.
And let's see. Isn't the magnetosphere of Jupiter and Saturn, doesn't it have too much for the moons? Don't they get scoured by these fields? Certainly on Jupiter, and certainly the inner moons of the Galilean moons, I think.
That's a really good question. So
what about
Saturn? I've thought about that. Yeah, I've thought about that. Well, let's take a step back. Look at Earth. For a second, look out your window, look at Earth. So we know that there's a South Pole. In fact, I've been to the South Pole. The cover of my book is the South Pole. And there's a North Pole. That's where Santa lives. And there are 2 other poles that you may be familiar with. There's actually a few other poles, but let's just stick with the other 2. What are the other 2 poles that you're familiar with, Tony?
The magnetic poles?
The magnetic poles. So where are the magnetic poles? Out of coincidence, they're actually fairly close to the geographic North and South poles. One of my friends, Robert De Laurentiis, he has a channel called Flying Through Life. He's flown around the world equatorially, and now he's flying around the world circumpolarly. And he already reached the South Pole about 5 months ago, and he's going to head to the North Pole in a few months in his own plane. And so I'll put an interview I did with him on my channel soon. But anyway, He's also going to go over the North Magnetic Pole. And it made me think, the North Magnetic Pole is very lucky that it is close for us, that it's close to the geographic pole. Why? Because the geographic pole is frozen over and inhospitable. In fact, there's no continent there, right? There's no continent at the North Pole. The South Pole, there is a continent. And yet, if the cargo plane stopped flying to the South Pole, I would not be talking to you. I would have died long ago, because it's only accessible a few months out of the year at the South Pole. It's so cold and planes can't fly there, et cetera, et cetera. Now, think about it. If the magnetic poles were close to the equator, where human life can flourish due to the temperature being permissible for life to exist, but the magnetic poles were there, what also showers down upon the Earth at the magnetic poles? Cosmic rays. So it might be, if the magnetic pole of the Earth was on the equator, that we wouldn't have much life on the equator, and life would be forced to go to the northern and southern poles, away from the radiation belt that gets funneled from cosmic radiation and the auroras, et cetera, and solar radiation. So anyway, this is all just to say that we have this incredible luck, if you want, or you can think of another explanation, I suppose, that put the geographic poles close to the magnetic poles, so that we could live and not be bombarded. Our DNA would not be completely altered and modified by this awful cosmic radiation. So just something to think about. Even on Earth, it's almost a happy accident that we don't live on a planet like Uranus or another planet where the poles are directed towards the sun, and they have very different properties from the hospitable planet that we have on Earth. So everything has to line up. That's why I think the most likely value is 0. I think Chris grossly overestimated it.
Yeah. Okay, well, Raj has a good question I'll ask. What do you both think of sending orbiters, rovers, etc. to Uranus, Neptune, and their moons?
Well, rovers on the surface wouldn't do much, but on the surface of the planet. But on the moons, sure. I think it'll be very interesting. I mean, the problem is it takes so long. Like the New Horizons spacecraft was one of the fastest. Yeah, it took 9 years. You guys had them on the show. The guys who wrote the book about the New Horizons. Now that was incredible, right? But imagine it had to slow down and orbit around the planet Pluto, or whatever it's called, planetesimal.
Minor planet Pluto, MPP.
Minor planet Pluto. So it would need almost as much fuel as it took, not to blast off from Earth, but to accelerate to 25,000 miles an hour, whatever it was doing. So it would require tremendous technology that we just don't have. Can we send micro rovers there? Perhaps, but they're very different from Voyager or from the Sojourner and so forth that are on Mars.
Yeah.
So well, it's great talking to you, Tony.
Yeah. Okay. Yep. That's it.
Are there any other quick questions? We can wrap up and then resume in a couple weeks. I think you're off. I'm off, and then let's connect back in July. I do want to turn people's attention to a kind of a different podcast that I did this week with Jim Simons, who's called The World's Smartest Billionaire. He, of course, is the patron behind the Simons Observatory that I co-lead with 300 of the smartest people on planet Earth. But he's also a mathematician who's made foundational contributions to the theory of what are called differential forms and other objects. And the last thing I'll say about him is I think he's one of the few scientists living that Eric Weinstein actually looks up to and respects. So it's fun to have him on. And I actually asked Jim, I said, Jim, do you know this guy Eric Weinstein? He has this obsession with you. And he's like, no, I don't know him. But and I told him what he's interested in doing is basically trying to get a Nobel Prize for Jim Simons. But anyway, it was his first and probably only podcast interview that he's ever done. So I hope people will tune into that. A lot of people have watched it. He's an amazing individual. That was this week. Next week, I have Adam Rees, Nobel laureate Adam Rees video on Monday.
That'll be a good one, really good one.
And then we should talk about the conversation I had with James Beecham, who's kind of arguing that we have to spend $20 billion or more to build a next generation particle collider. So I'd like to talk to you about that.
Next
Find those videos on my
particle
channel. Particle collider.
Oh, okay.
A successor to CERN that's 4 times bigger diameter.
Wow. Yeah, let's do it, man. Don't they have to let Switzerland know whenever they turn that thing on? They have to say, hey, we're getting ready to turn on this collider. So I don't know how they're going to power something that's even more powerful than that.
The lights are going to dim. Yeah,
they
some
have to,
people
like,
say
they have to call
outrageous.
Switzerland, the government. We're about to turn this thing on. Can you give us more power? And Switzerland goes,
Really?
yeah, okay, we got to plug it in now.
We'll get rid of our Swiss Army knife factory for a couple minutes.
Yeah, definitely. Okay, well, Dr. Bryan Keating, thank you for joining me. Like you said,
Thanks,
we'll be back in
everybody.
2 weeks, it sounds like. Go to Brian's channel, Dr. Bryan Keating, youtube.com/Brian, Dr. Bryan Keating. You can see all of his interviews here. The one we're talking about, the link is in the description box. Go listen to his podcast, subscribe to it. Did you ever get on Spotify, by the way, or are you still on iTunes? Or
we're working on it. Yeah, we're working on it now. Yeah.
Because you need to get on all of them.
Yeah. Oh, I think there's a broken link in the description that's saying there's a broken link when I go to the video on your channel.
On my channel? Okay, I'll fix it right
yeah.
now. The one to the interview, I think. Okay.
The one with Chris, yeah.
It might have been the copy paste didn't work. Okay, I will. Okay. I'll put it in, and
awesome.
We'll fix it right now. Thank you, Brian. You have a good couple of weeks. I'm going to go on holiday next week, so I will see you when we get back.
Thanks, everybody. Bye-bye.
Bye-bye. Okay, so on behalf of